Hebrew, English? English? שפת שלי זה C++. אז יאללה. So I like to present the article that I heavily researched, and it actually became the basis of a POC which I did, which uses machine learning to detect malicious files. In this article, it was malicious PDFs. It was the most interesting way to start, and I don't regret it. So a little bit about me. Born and raised in Houston, Texas. Moved to Israel in 2010. I got a B in telecommunications engineering from Machon Lev. And I work in machine learning and cybersecurity, and I have a passion and avid interest in the world of AI. It's amazing, and that's why I'm here. The two articles, one is written by Yuval Elovici and a few other professors from Ben Gurion University, and the second article is written by Jarly Kittleson, published in 2011. We live in a digital world. A world where everything is on the computer. Documents, emails, even your airplane ticket is now called an e-ticket. Mail is now an email. And a very popular way for this information to be transferred is using a PDF. And as we all know, PDFs are amazing. They're light, they're portable, they're unified, but unfortunately, they do pose some risks. Let's start learning about the structure of a PDF. A PDF is a set of interconnected objects built in a hierarchy. The file structure consists of a header, a list of objects, a cross-reference table, and a trailer. It's a little bit cut off, but PDFs offer many capabilities beyond simple text, such as JavaScript code, encryption, and even multimedia images. This is a diagram of a structure of a PDF. A second. There's the laser. The header includes the version number. The body includes different objects. Some of these objects could be strings and text, like what everyone knows, but we'll soon see that there are other types of objects that are a little bit more interesting. The cross-reference table includes the locations of all the objects, and the trailer includes the location of the cross-reference table in the file. So when you open a PDF, everyone's used to opening it on Foxit or in Adobe PDF Reader. But if you open the PDF in Notepad or Notepad++, you'll actually see the file structure of the PDF. You'll see the header. You'll see the different objects. In this case, it opens with the open action object. We'll learn about that soon. It has the cross-reference table of all the different objects and the trailer. So they're different objects, as we said. Images, strings, text, booleans. But there are other objects that were meant to be good, but can be exploited for the bad. For example, encryption. A PDF can be used and it could be encrypted for a signature, for example, in order to protect the contents. But a hacker could use the encryption to obfuscate and to camouflage the malicious content a PDF can contain. Or JavaScript. A PDF is able to execute code. Naturally, a person would want to use the code for form validation or to submit the form to the internet. But a hacker could use JavaScript to actually execute malicious code of a virus. Open action is the ability of a PDF, and it's a possibility that it offers, which triggers an exe or command upon first opening of the file. An attacker could use the PDF to open another exe which is sitting somewhere else on the machine, or even in its own payload. Rich media is the ability for a PDF to play Flash, but Flash has many other vulnerabilities that have been discovered. Here's an example of a PDF open in Notepad. And you can see it's an open action /F. /F means to open a file. What is the file that's going to be open? calc.exe. Now as a reminder, that exe could be anything. And in other words, the second you open that PDF, that exe is going to be run. I'm going to show you the demonstration of that exe being opened. I'm just nervous I'm going to be short on time, but it's interesting. I think we'll get to it. So now we saw the issue. PDFs could be dangerous. The POC is to use machine learning to mitigate this issue. The authors used 5,000 benign PDFs and 5,000 malicious PDFs for the initial data set. The benign PDFs were obtained by different crawlers through the internet, file sharing, and network shared drives. And they're even created synthetically, converting a doc to PDF, and etc. The malicious PDFs were a little bit more interesting. They're obtained from the darknet, file sharing, and file corpuses. With all the duplicates removed, all the PDFs were scanned in a regular antivirus program as the baseline to label all the data. And that was the ground proof of the data. The ground truth, I'm sorry. Based on the work of Stevens and Bacchus, a data set of 18 features were created. Some of these features are a mismatch between object and end object, or the presence of a trailer, the number of pages in the document, the presence of JavaScript, or even the open action. Another 2 different data sets were created with different feature selection algorithms. One is using the Golub score, and the other one is using the GEFS feature vector, one which yielded 7 features, and the other 5 features. And as a reminder, we still have our original data set of 18 features. With all 3 data sets created, one for each different type of feature vector, they were tested with 5 different classifiers: a decision tree, a BaseNet, SVM, RBF network, and a multi-layer perceptron, all with 10 cross-fold validation. The results were stunning. The 7 and 18 features performed best with SVM and the random tree with a 99.5% accuracy. The 5 features, which seem like very little features, they perform best for the RBF and the BaseNet. But the RBF performed worse, and the BaseNet only came into 3rd place. If you look at the balanced success rates of all the data, you can clearly see that a reduction from 18 to 7 features has virtually no impact on the performance. However, a new 11 feature vector was created based on the Golub score, the other feature selection algorithm GEFS, and expert analysis. With this, using an SVM and 10 cross-fold validation, a 99.56 accuracy was achieved with a 0.9918 area under the curve. The best success rate, better than any other of the feature vectors we saw. So we saw the structure of a PDF, and we also visited the different risks a PDF could carry. Using machine learning, the SVM reached an accuracy of more than 99% to detect a malicious PDF. This method was called static file analysis because we took the file and we analyzed it statically based on the file structure. Now I know what everyone is thinking. Why not use an antivirus? Why am I here? Why are we talking about machine learning? The answer is that an antivirus, as of now, doesn't respond well to file variants. What does that mean? If a file changes a little bit, such as a string being changed, or the number of pages, or a name of a function, or even the structure is altered a little bit, it's a different file. And therefore the antivirus program, which takes every single file, and based on the footprint, it creates a signature for its virus definition. Every single variant will create another definition. So what does that mean? That means an attacker could take a current virus, could change it a little bit, and there you go. The viruses don't know about it yet. It could be a potential 0-day. And that's where machine learning comes into play. Because it doesn't work on signatures or footprints. It works on patterns. Based on the number of pages, for example, or open action, doesn't matter what the names of the functions are. Machine learning will detect the pattern, and based on all the pre-learned information, is able to detect the file. A next step I have to offer, and it's a step that I did in the project, is to analyze the behavior of a file, running it dynamically with the behavioral report of the file by running in a sandbox, for example. And with that information, you're able to include that with the static file analysis and have a full analysis of the file, both statically and dynamically. I would like to show you the video. It's a little bit interesting. It's only 7 more seconds. Don't worry. So, so using social engineering, a person can convince you, or an attacker can convince you, to open a malicious PDF. So always the first step is to get that on your computer. The second step is to get you to open it. So here's the user innocently opening a PDF. Here saving it. Pause. So what happened was, you saw right before this, so I chose this example because it's an exe that's invalid. So we'll see that an exe was tried to be opened, and because we see an error, we see that was actually ran. That error message, that warning message that you just saw, is a new thing PDFs have to offer because of this issue. It warns you that a file is going to be open. What happened was that when the PDF was open, the open action command was to open that certain exe on the computer, which could be a virus. And therefore, I hope you can see machine learning can save the day. Thank you.
אז תודה רבה מתתיהו, תודה רבה לכולכם שבאתם. נהנינו מאוד להציג, תודה רבה לכולם.